So we're now getting on to the absolute behemoth of physics, and that is energy. So energy is defined as the ability to do work and also has the unit of joules. Without it, we wouldn't be able to move with this thing called kinetic energy. Electrons won't be able to move in a circuit with electrical energy, and we wouldn't be able to move things, which we'll get as potential energy. Now, there are way more different kinds of energy. We wouldn't have cookery, or most forms of cookery, without chemical energy and heat energy. There's just so many different kinds of energy, but now we'll mostly be focusing on kinetic and potential in this particular section. There is no one general equation for energy. There's so many different kinds. I'm going to go through two in this video, which are the main ones for energy and work and most of classical mechanics. And that first one being kinetic energy. So, kinetic energy is the energy due to the movement of a body. So if something moves, like this aeroplane here, it will have a velocity, and of course every classically modeled particle has mass. So with the mass and velocity, the kinetic energy is 1/2 times the mass times the velocity squared, or 1/2 mv squared. The symbol for kinetic energy is E sub k, so it's just E with a tiny k next to it. It's 1/2 mv squared. The second kind is gravitational potential energy. So it's the energy due to, well, it's a bit of a complex definition, but it is the energy that an object has due to its relative position to a fixed point. So this man here on the stairs, we could say that if we draw this little baseline here as our reference point, then he is some height h above that reference point. But instead, if we change our reference point to somewhere, say down here, he will have a new height I'll call capital H. So it really depends on what your reference point is. However, for most physical problems that we're going to be discussing, the reference point is the ground. So the floor is where we're going to consider the height to be 0. So it also represents the maximum energy an object will output along its journey from its position to that fixed point. If it travels to that fixed point, it could be caught, for instance, say midway through the journey, so he could maybe fall onto a trampoline that's some other height above the ground, or above or below the reference point. The formula for gravitational potential energy is mgh, so mass times gravitational acceleration times height. We can also generalize it if we have a slant. So if we're going up a slant, angle theta, this is the height, and this here is the length it travels up. We can say that sine theta is h over L, so h, the height, is L sine theta. So that's just another way of representing potential energy. So some objects, or some books even, simply label this generally as potential energy, so they don't even specify that it's gravitational. But there are many different kinds of potential energy. We're going to get to elastic potential energy when we get to simple harmonic motion, and electrical potential energy when we get to electricity.